In this we are going to learn how IIR filter is going to be designed. First we will go with the realization as in terms of FIR. Here also we are going to use a direct form, cascade form, parallel form. Okay. First we go with the one problem. Here a problem is given. A transfer function is given for us. Next, whether it is, we have to check whether it is FIR or IIR. Next, we have to write a direct form 1 and also we have to write a direct form 2. We have to realize both. To find first what is they asked, we have to find whether a given transfer function is whether a FIR or IIR. To do that, first we have to solve the given equation, that is h of z is equals to 3 plus 4z divided by z minus 0.5 minus 2 divided by z minus 0.25. Just take the LCM, multiply of that, and if you solve this, multiply these two first and then with this 4z and next 2 with the z minus 0.5. If you solve that, you will be getting as the equation as 7z square minus 5.25z plus 1.375 divided by z square minus 0.75z plus 0.125. Okay. Here numerator, both the denominator are z power is 2 only. Both are equal. Means this is the system has poles and also as well as the zeros. Poles represents your numerator, zeros represents your numerator, poles represent your denominator. Okay. So hence the given transfer function is of IIR filter. Okay. When you go with the FIR filter, your FIR filter is consisting of only the numerator part. It's not having any denominator part. Already we discussed in the programming part while explaining in the lab how FIR and IIR is going to be differentiated. Okay. Next, this is what we decided. The given transfer function is of IIR. Next, we have to do for the realization of direct form 1. To do that, first represent the equation in terms of z inverse. What you have to do? Just take, multiply with the z raised to minus 2 in denominator and also for the numerator whole. Okay. If I multiply z raised to minus 2 for numerator and also for the denominator, I will be getting the equation as here, that is h of, we will erase this, h of z is equals to 7 minus 5.25 z inverse plus 1.37 z raised to minus 2 divided by 1 minus 0.75 z inverse plus 0.125 z raised to minus 2. Compare with the standard equation. Already you wrote IA. Okay. H of z is equals to b naught plus b1 z inverse b2 z raised to minus 2 1 plus a1 z inverse plus a2 z raised to minus 2. Okay. What are our b naught value? B naught is going to be 7, b1 is going to be minus 5.25, b2 is 1.37. Similarly, a1 is going to be minus 0.75, a2 is going to be 0.125. This is how you will get. Next, we have to draw the direct form 1. Just represent how many delays function we need, that is z inverse z raised to minus 2. For that reason, 2 delay functions represent your b0, b1 and b2. In this case, a1 and a2. If you represent this, you will be getting your direct form 1. Next, to get